Okay, I thought I'd go through the free responses on page 5 and 6. This one's just important to note. It's f prime in the graph, not f. And it's also important to note that even though this has 4 parts, I don't think this is ever, would ever get you to 9 points nowadays. This is from like, I don't know, 2000 or 2003. So it's not that long ago, but it's still kind of like out of date for how many points it takes. So this is f prime. You've got tangent lines, of course, here, horizontal ones here, here, and here. And then a vertical tangent line at x equals 3. So it does get to be vertical here. That's just kind of important to note. Find where f, not f prime, f has a relative min. Okay, so remember we're looking for, to use the first derivative test, anytime f prime changes from negative to positive. So this is going to be a relative max, this would be a relative min. So part A is at x equals negative 1 because f prime changes from minus to plus. Very simple work. B. Find where f has a relative max, so you would do the others then. So at x equals negative 5, because f prime changes from plus to minus. Okay. And then part C, find all values at which f double prime is less than 0. So that's asking about concavity, right? That's concave down is the interpretation of this. So concavity, right, is not only tied to where the second derivative is negative, it's also tied to where f prime is decreasing. So that's what we're going to be looking at on this graph because this is f prime, right? So this is decreasing from negative 7 to negative 3 and from 2 to 5 for all values of x. So that specifically means a interval like this because it's not specific places, okay? Because f prime is decreasing. Okay, the real hard part in this one is part D. For what value of x does f obtain its absolute maximum? So you want to know where f is going to reach its peak, right? So you could kind of try to sketch it if you wanted to, analyze the increasing, decreasing, positive, negative. You could also think about the area under the curve where this picture accumulates the most area, right? So its absolute max is going to be, it could be where the relative max was, which was at negative 5, right here, okay, because that's accumulated this much area up until then. So we would want to think as the value of f would be whatever initial condition it was plus from negative 7 to x under this curve. So you could think about it that way. This is too many x's. I guess I should call this dt. Plus whatever initial condition you had, but I don't know if you would actually, you wouldn't be given one here. So we would just go ahead and kind of look at, then it starts decreasing, right? Because it gets me all this negative area. And then it stays positive and above the x-axis for the rest of the time. So we're going to say that at 7, it actually reaches its absolute max. So you have to consider the endpoints. Considering x equals negative 7, negative 5, and positive 7, the absolute max occurs at x equals 7. You don't know what its value is, right? Just its value of x, okay? Because f prime accumulates the most area over, let's say, negative 7 to 7 compared to negative 7 to 5. Okay, lots of different ways to say this. I can go maybe, we'll hit a couple more of these as time goes on. This is a great question. This is one of my faves. This is an amusement park question, so think Six Flags here. This is probably something that an analyst does that works for them, right? This is how many people are coming into the park, and this is the rate that they are leaving the park. Okay, so these again are rates. We saw this. We'll see this again later in the week. So these are measured in people per hour. Time is measured in hours after midnight, so that's important. So t equals 0 is 12 a.m. These functions are valid between 9 and 23, so that's 9 a.m. up until 11 p.m., which is about when the park is open, right? Hours, yeah. At 9, nobody's in the park. How many people have entered the park by 5? So it just says how many people have entered. It doesn't say how many people are there. So for part A, we are just going to integrate from 9 a.m. until 5 p.m., right? And we're going to use the E of t entered function, right? So we just have to write E of t here. You don't have to write the whole function in there. And then it'd probably be sensible to put these in the order that they are there. So 15,600 divided by t squared minus 24t plus 160. And while I'm here, I'll just put the other one in. T squared minus 28t plus 370. Okay, so when I go back, math 9 to 17 under y1, that ends up with, to the nearest whole number, right, 6,004 people. Part B. Price of admission is $15 until 5 p.m. After 5 p.m. it goes down to $11. How many dollars are collected in the park on a given day? So there's two ways to do this one. I think to me, since you've already calculated the 6,004, I would take 6,004, right, times the $15 it costs them to get in, plus $11 times how many people come in the rest of the time, right? Okay. How many dollars? Round to the nearest whole number. So again, you would just type this in, 6,004 times 15 plus 11 times math 9, 17, 23, and again, this is still y1, and then you would round to the nearest whole number. So you would say $104,000 a day. Isn't that crazy? And just think about how much more Six Flags charges than this. So that's a lot of money per day. All right, part C. H is the difference between the two functions. So entering minus leaving, these are their rates. So this is going to be probably, well, I can't give you the answer. The value of h of 17 to the nearest whole number is 3,725. So they're saying h of 17, right, which is the integral from 9 to 17 of this, is 3725. Find h prime and explain the meaning of both of them. Okay, so I would explain h of 17. That's how many people are in the park at 5 p.m. Right? Because again, it's integrating. This is counting up how many people have entered minus how many people have left. When you take that into context with it, you're counting up how many people are total. Okay? H prime of t, if I just take the derivative of this, I don't know, accumulator function, I would get e of t minus L of t, right? And I have to plug 17 into the h prime of 17 is e of 17 minus L of 17. Which is what? So you can just do that in the home screen. y1 of 17 minus y2. Good one. y2 of 17. Oops, negative 380. 0.281. So this then is indicating that the amount of people in the park is decreasing, right? Because this is the rate of change of the people in the park. Okay, so this indicates the amount. The rate that, let's say it this way, people leave is greater than people arriving. And it's important to have rate in your justification, okay? Because that's what that is. Okay, D, last one. At what time does the model predict that the number of people in the park is a maximum? So we're going to take this guy, right? We're going to find its intersection. We're going to consider how many are in there at the endpoints. Okay, so really we're doing this for certain times. We want to know how many people are there. So we need to know at time 9, at time 23, and then whatever the intersection point of these two functions is, right? So I'm going to change my window to go all the way out to 23. This should be enough. I don't know. Let's see. JK, so let's make this bigger. So this intersection point here is going to be right where they, there could be a maximum there, 15 points. And let's think again about what's going on. this was the first one, right? So this is entering the park is greater than how many are leaving up until 15 hours past midnight, right? So it's 3 p.m. So this will probably be the maximum here, I would guess. Okay, but you can just go back to the home screen. We calculated how many were in there at 9, right? We know they told us at 0. Probably at 23, it's going to be 0 again, right? Because everyone left. And so then if you did math 9 to count how many people are in there, let's do 9 to, I didn't store it, it's going to be x right now, and let's do y1 minus y2. Should be a big positive number. Yeah, so that's greater than how many were in there at age 17, right? It grew. So that would kind of make sense with the information that's been provided. So this is not the answer. So even though I went out of my way to find this to kind of help you guys understand what's going on here, this isn't my answer because it says at what time t. That's just my verification that it was what I was hoping for. So at t equals 15.794. And I would just say because h of 15.794 is greater than h of 9.